I prepped my second chromatogram, one with the metal ions. I have my known ions on there, 3 of them, and my 2 unknowns on there. Now when I put it into my beaker, which this time is a smaller beaker, again I want to look and see how deep the liquid should be. I don't want it very deep, because if it goes up to the line, my ions go in solution and not up the chromatogram. So I don't need a lot of solution. And now I should staple my chromatogram, because I don't, and again, I want a little gap. I don't want overlapping. And some people are really good at this, some people are not. I'm not. Okay, so notice I have a nice cylinder. So I'm going to put that into my liquid developing solution. And this, remember, is HCl and acetone. Again, I'll put an evaporating dish over the top to sort of create an atmosphere that's saturated with those vapors. Now, because this one doesn't show any colors, I'll have to just watch where my liquid is. Okay, now let's go back to the food dyes. Now, if you look, you can see the development of the food dyes. Just a second, I'll take the lid off and rotate it so you can see. Notice how they're moving. You get some separation. And notice it's almost near the top. So we know that is done. So what I'm going to do is take it out and mark my solvent front. You can't, it's sort of hard to see, but it's there. It's how wet the paper is up to this top. I'll mark that, and that's my solvent front. And then it has to dry, which will take a few minutes. So I'll take it out, take the staples out, and I'll show you as I lay it down here. Okay, I've placed my open chromatogram. I took the staples out and opened it up. I've laid it flat on a piece of paper, a paper towel, just to dry. Now I'm going to mark my solvent fronts, and they're not always linear because difference in densities. So we'll see how this plays out here. So if you notice, it's not a perfectly linear line, but that's okay. The odds of you getting a linear one or not. But if you notice, this was number 1, which was the red. This was 2, was green, this was yellow, and this was blue. These were your 2 unknowns. Your 2 unknowns. And of course, the observant student would look real quickly and say, I know what these are, so this one was probably what? Well, I'll let you make that call. And this one might be what? Now it looks like this probably could have run longer, which means we would have had to have longer paper and a bigger cylinder, a taller cylinder. And of course, I hope you realize as the liquid moves up the chromatogram, it moves slower and slower because it's going against gravity, and therefore it takes longer and longer. So the longer the paper, the longer to run time. Okay, so I'm going to let these dry, and now I'm going to go back and check on my metal ions and see how they are doing. Okay, I removed my chromatogram from the metal solution, opened it up, took the staples out, and now I've laid it flat on the paper to dry. If you notice, some of these ions are not visible, so we have to make them visible, and we use various chemicals to do that. So we'll let this dry a little bit, and then we will come back, develop it using chemicals. Notice iron has a little bit of color, and I left it in there a wee bit too long, so it went all the way to the top. And it goes very fast, but it should still work. Okay, so we got copper, nickel, iron, and our 2 unknowns. And you see the yellow here, you know that's iron. And if you notice in this unknown, there seems to be some yellow in there. Maybe not a lot, but there still seems to be some present. Okay. So on my data sheet, I noted the color of the original solutions. Then I noted the colors that it came off my chromatogram. So notice red had this color, green had 2 colors, yellow had 1, and the blue I'm sort of leaning towards 1. Now if you see all these little specks in there, that is just impurities that got on the chromatogram. It's probably through my fingers, through the toothpick, whatever. But notice those little specks are just impurities. And of course, if we had been doing proteins, we wouldn't be able to handle it because then your fingerprints would be everywhere on it because the proteins would be deposited. So first of all, I need to measure my solvent front. And notice I measure from my baseline to here. And of course, if you look, it's 7.5 centimeters. Okay, I should do my solvent front first. 7.5 centimeters. So that's my red one. My blue is 7.8 centimeter. Oh, I want millimeters. 75. 70. Yellow is about 79, and the blue is 80. So notice my solvent front keeps changing. This one was 75, and it kept going up. Okay, then I'll do my unknowns. Okay, my colors on my unknowns, this has got yellow, it's got blue, this one's got red, and there's a faint yellow. So my solvent front here is 8.3 or 83, and this one is 7.878. So those are in millimeters, or 7.8 centimeters. So I've measured those. Now I need to find the center of this. So basically I just circle the whole thing. My pencil's not going to stick because the paper's still damp. But if I say that's the center, and I want to find the middle of that. So that is approximately, it's about 5.5. So I only have one color, so I only have one reading. Then here I have 2 colors. So the center of my blue is about 72. Where's my yellow center? So I got to look this whole thing and find the approximate center, about there. So then that is about 4.5. Then I go to my yellow one, and this is approximately this thing. So I find the center about there, and that's about 5.5, 55 millimeters. Then I do the same with my blue. Now my blue, some people might want to go here and here. I'm just going to concentrate on this little area here. And I'm going to put that down as about 6.2. I'll do the same with my unknowns. Okay, my number 5, or A, has 2 spots. I'm going to find the middle of the blue, measure that, and that's about 77. The blue, 77. The yellow, the center is about there, and that's about 4.6. My red, now I see the yellow, and I see some yellow in there, and I see some red. So I'm going to say my red is mostly at the top. It looks like it's about 70. whereas my yellow is very faint, but I'm going to guess about there. So it's about 4.5, 45. Okay, so I have measured those. So now I can calculate my RF values. Now remember, I take the center measurement divided by the solvent front. So this number divided by that. So in my first scenario, to get the RF value, now there will only be one RF value because there's only one color. So to get that, I will, it's 50. Let me grab my calculator. And so it'll be 55 divided by 75. So my RF value is 0.73. Okay. Now remember, you cannot have an RF value over 1. You cannot have an RF value. Now since there were two colors here, I will have two RF values. It will be the 72 divided by 78. It will be the 45, not 4.5. 45 divided by 78, so 72 divided by 78, so 0.92. 45 divided by 78, 0.58. Okay, so here I only have one color, so it'll be 55 divided by the solid front, 79. So this will be about 0.70. Here, 62 divided by 80, and 0.78. Then I need to do my unknowns. And my unknowns each have two colors, so I'll have two RF values. So it'll be 46 divided by 83. So 0.55. 77 divided by 83. And then 78 divided by 80. 70 divided by 78. It's approximate. $45 divided by 78. Okay. So notice all my RF values are less than 1. Okay. Now, I assume this would be red. My RF value for red, when I calculated originally, was 0.73. When I calculated my red over here, it was 0.90, but it could be because I could have picked a bigger box. I picked a little area here. Could have picked the whole thing. Okay, so the RF values may not always mirror exactly what, but when you look at this, you can certainly tell you that number 2, which was green, is made of these two colors. Now below here are just some more generic questions that you've asked that come off your chromatogram. So I won't go through those, but I'll let you do those calculations.